Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the third question from the mathematics paper 1 examination, which was written in June in the province of Gauteng in the year of 2024. Please do expect a total number of 10 videos since the question paper had 10 questions in total. This simply means that each and every question will have its own video. So guys, please do take this seriously. I strongly believe that knowing how to tackle exam questions will help you to, it will help you have an edge whenever you're writing your mid-year exam, preliminary exam, and most importantly, your final exam. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, first question, we are being asked that for which values of x will this expression over here exist? Okay, I'm given a sigma notation. I'm definitely dealing with number patterns, how it's together, and I see the term that says infinity there. That means this is sum to infinity, and the only sequence that can give me a value whenever I add terms from the first term until infinity is a geometric sequence. Are you together? And that type of a geometric sequence must be convergent. Are you together? Which simply means that the sequence should have a ratio that is always between -1 and 1. Please do keep that in mind. Now, so for me to find the value of x, I must simply know the common ratio of my sequence, right? But before I do that, I must at least generate 3 terms of the sequence. All I have to do is to just substitute values of k. Are you together? The first value of k is 1, so my first term will just be 4x minus 1 to the power of 1 plus the second term, I'll just increment by 1 over there. Né? So I'll simply have 4x minus 1. Since k was equal to 1 initially, now k will be equal to 2 plus 4x minus 1, and then now k will be equal to 3. Therefore, my common ratio, which is just t2 all over t1, is basically equal to 4x minus 1 squared all over 4x minus 1, and then this will simply give me 4x minus 1. This is my common ratio. Are you together? So I know that my common ratio, which is 4x minus 1, should be between -1 and 1 for this over here to exist. Okay, and then all I have to do, guys, is to isolate x. So the first thing I need to remove is that -1 over there. How can I remove the -1? By just adding 1. Just doing the direct opposite. -1 and 1. Just add 1 over here, and whatever you do inside here, you must do also on the other 2 sides. So I'll be left with just 4x is between 0 and 2. 0 and 2. Are you together? Then all I have to do now is to just divide every term by 4. Then I'll be left with x. 0 divided by 4 is 0. 2 divided by 4 is half. So x must be between 0 and 1 over 2 so that this entire expression will exist. That's how, guys, we're supposed to tackle this question over there. Okay, and then question number 3.2. We are told that the figure below shows the pattern. The figure below shows a pattern of 5 circles, which are just touching externally, whose centers lie on a straight line of length L units. Okay, the radii of these circles form a geometric pattern where the radius of the smallest circle is 3 units and the radius of the 5th circle, which is the largest circle, is just 48. Excuse me, it's just 48 units. Nah? Okay, I'm told that the radii, they form a geometric number pattern, which simply means that the first term of my geometric pattern will be 3. I do not know the second term, don't know the third term either, as well as the fourth term, but I do know that my fifth term is equal to 48. Are you together? Okay, and then on the first question, they want us to determine the common ratio of the geometric number pattern formed by the radii of the circles. So our common ratio is basically equal to, okay, I know that T5 will basically be equal to AR to the power 5 minus 1, right? And this will just give me AR to the power 4. Remember that, guys, the nth term for geometric number pattern is always like this, né? So T5 is always AR to the power 4. I know that my fifth term is 48, and the value of A is the first term, right? That's just equal to 3. I can divide both sides by 3, and then I'll simply have R to the power 4 being equal to 16. Then I'll take the fourth root on both sides, fourth roots, then R is equal to plus or minus 2, and then R is equal to 2, because the radius of a circle cannot be negative. Not the radius, yeah, the radius cannot be negative, so my common ratio is just 2 and 2. So that's my common ratio over there, né, guys? So this simply means that the radius of circle number 2 is simply equal to 6. The radius of circle number 3 is equal to 12. The radius of circle number 4 is 24, and hence the radius of circle number 5 will be 48. Okay, now they want us to determine the length L. This over here, guys, will just give us this is the sequence for our radius, right? However, guys, L should be a sequence for the diameters of the circle. Are you together? Because this is the diameter of the first circle, diameter of the second circle. It goes on and on and on and on like that, né? So if I can find the sequence for my diameters, I can simply find the length of L. Are you together? So the sequence for my diameters, please do note that, guys, the diameter is just 2 times the radius. Are you together? So the first term will just be equal to 6. 3 times 2 is 6. 2 times 2 is 12. 12 times 2, that's 24. 24 times 2, that's 48. 48 times 2, I believe that's 96. So these are my diameters. The diameter for the first circle is 6. The diameter for the second circle is 12. The diameter for the third circle is 24. The diameter for the fourth circle is 48, and the diameter for the large circle is 96. Remember that the diameter is always 2 times your radius. So this is our common ratio over here. That's 2, 2, and 2. Né? So we can simply calculate the sum of all these numbers, because L is just the sum of all these numbers. Né? You can simply add them one by one. But just to be a bit smart, just say Sn is equal to A, R to the power n minus 1, and all over R minus 1, right? A is just equal to 6. Remember that, guys, my first term is 6, né? So A is 6, R is 2 to the power 5 minus 1, all over 2 minus 1. And then this will simply give me an answer of 6 multiplied by 2 to the power 5 minus 1, all over 2 minus 1. That's just 186 units. So L is equal to the sum of the first 5 terms of my diameters, which is just 186 units. Okay, now I'm told that the pattern is extended by 5 more circles to to 10 circles. Né? Calculate in terms of pi the total area of the circles of the new pattern. The total area of the 10 circles of the new pattern. Okay. Remember that, guys, the area of a circle is always pi r squared, right? So the area of my first circle will simply be pi r squared. The radius of the first circle is 3, right? And then the area of the second circle, it will be pi r squared as well. Third circle, pi r squared. It will go on until the 10th the 10th circle over there. Né? So I know that the first term of the area of my first circle, this will basically give me 9 pi, 36 pi, 144 pi. It will go on until the 10th circle. Now, if I can check there, guys, these areas, they form a specific type of a sequence, and this sequence has to be geometric. Why? Because the radius form a geometric number pattern as well. So 36 divided by 9 will give me 4. The ratio is also 4 over there. Né? So I know that the first term is 9 pi. The common ratio is just 4, and then n is equal to 10. I just want to calculate the sum of the first 10 terms. The sum of the first 10 terms, right? So this will basically give me Sn being equal to a to the power r, a multiplied by r to the n all over r minus 1, right? Then I just need to substitute. The value of a is equal to 9 pi. 9 pi. And then the value of r, that's 4 to the power 10 minus 1 all over 4 minus 1. Are you together? And then this will basically give me 9 multiplied by 4 raised to the power 10 minus 1 all over 3. This will give me 3,145,725 pi unit squared. This is the total area, guys, of my 10 circles. Now, that's my total area. So the total area is equal to the sum of the first 10 terms. That's just 3,145,725 pi unit squared. That's how, guys, we're supposed to deal with question number 3 over there. So please do stay tuned and wait for more videos. Thank you.